So let's discuss all about pointers. So when we say pointer, a pointer is a memory address of a variable. So that means when we are talking about a pointer is also a variable, but it points to the address of another variable. So let's illustrate how we actually deal with pointers. So if, for example, if this is the memory allocation, okay, let's say for example, this is just a simple variable, and let's name it as num. Okay, so if this is num, and previously, if we want to populate or ask for the input of num, we can use the assignment operator, which is, for example, num is equals to 5. Or we can also use cin greater than sign and then num semicolon. So this how are we going to get the input or populate the value of this particular allocation. So to make assigned value of 5. But this time, we're going to use pointer, okay, for this particular variable. So again, for the definition of the pointer, pointer is a variable that points to the address of another variable. So take note that num is a variable. So if I'm going to use a pointer variable, so let's have this. I'm going to create another storage or another memory or another variable. Let's make it variable PTR. It means that this is a pointer variable. Okay. So that means that I'm going to point this to the address of num. So how am I going to do that? So let's say, for example, when we are talking about address, address is the system address, no? So for example, the system address is always in a hexadecimal format. So let's say, for example, that the address of this one is 1100XH, for example. So what will happen if I have a pointer? Okay. So the first thing that we're going to deal with is we need to assign this pointer PTR to the address of num. So what will happen is I'm going to point this pointer variable to the address of num. So what will happen is the content of this is not the value that we're going to ask for the user, but instead the pointer PTR handles the address of this particular variable. So this becomes 1100XH. Okay. Now, if I'm going to populate this variable, I'm not going to make use of num. I'm going to make use of the pointer PTR or PTR. So since pointer PTR handles the address of this particular variable, I can ask the user to input the value using the PTR variable or using the pointer variable PTR. So how are we going to do that? So please take note that before we have num is equals to 5. So this time, if we're going to make use of pointer PTR, okay, to get first the address, no, to assign the address of num to pointer PTR, we need to use this syntax. Pointer PTR equals ampersand sign num. So this means that I'm already pointing my pointer PTR to the address of variable num. So that's our illustration earlier. Next, after doing this is the first step. The second step is we can already ask the user or assign value to num. How are we going to do that? So we're not going to make use of this one. Instead, the other option is make use of the pointer PTR. So to make use of the pointer PTR, we're going to make use of the asterisk sign. Okay, so what's the equivalent of num equals 5 if we're going to use pointer PTR? Asterisk PTR equals 5. So this means that I am getting the content. Okay, asterisk means I am assigning the content of where pointer PTR is pointed, and I'm going to assign a value of 5. So pointer PTR is pointed to this address, and this address is the variable num, and I'm going to populate it to 5. Okay, next, the input statement. So to make this input statement correct from using pointer PTR, so I'm going to use cin and then asterisk PTR semicolon. So that's how we are going to make use of pointer declarations to access, okay, and to point it to another variable. So that's the definition. Okay. A pointer is a construct that gives you more control of the computer's memory. So please take note of that we are talking about computer memory. Okay, so why we use pointers in C or in C++? So previously, it is the only way to express some computation it produces compact and efficient code, and it provides a very powerful tool. So in what particular area of topics we can actually use pointers? So we can use pointers in array, in structures, and of course in function declaration. Okay, so take note of this. What is a pointer again? A pointer is a variable which contains the address in memory of another variable. We can have a pointer to any variable type. So please take note of the declaration. So since the content of this one is 5, so how are we going to declare that? So the first declaration will be the simple variable. So int num semicolon. Then how are we going to declare a pointer variable? So if we're going to pointer PTR to variable num, whatever the data type of num should be also the data type of the pointer PTR. So since num is data type int, so we need to declare also pointer PTR as data type int. And then to make it a pointer variable, we usually use an asterisk sign. Okay, and then the pointer variable name, which is PTR semicolon. Okay, so this is for the declaration. So this is the declaration of num, and this is the declaration of pointer variable. So don't forget the asterisk sign. Okay, so asterisk means you're already pertaining to a pointer variable. Okay, so again, ampersand sign means the address of a variable. So this one, ampersand sign means the address of the variable. And the other one, the asterisk sign means contents of an object pointed to by a pointer. So this one means content. So the content where pointer PTR is pointed is equals to 5. Okay. So how are we going to declare pointer declaration? Again, the data type, and then we usually use the asterisk sign, then variable name. If you have more than one pointer to be declared on your program, so you just separate it with a comma sign and then the other pointer variable and ends it with a semicolon. So this is an example of how we are going to declare pointer variable. So double, then asterisk pointer 1, comma, asterisk pointer 2, semicolon. So this means that there are two pointer variable named pointer 1 and pointer 2, and we can only point that particular variable to a storage or to a variable which contains double type of value. Another type of declaring a pointer is using the type definition or type def. Okay, so how are we going to do that? So let's have a simple code here first so that we can actually use the type def as well. So I'm going to declare in main first. So let's have a declaration for simple variable first. Let's have num1, comma num2. Then I'm going to declare also int asterisk ptr1, and then the other one is asterisk ptr2. Okay, so what I'm going to do is I'm going to point pointer 1 to num1, and I'm going to point pointer num2 to pointer 2 to num2. Okay, so I'm going to assign first pointer 1. So ptr1 equals ampersand sign num1. So this means I'm already pointing my pointer ptr1 to the address of num1. Then the other one is ptr2 equals ampersand sign num2. So again, in this case, I already pointing my pointer ptr2 to the address of num2. Then I can already assign a value to pointer ptr1 and pointer ptr2. So let's say, for example, asterisk ptr1 is equals to 10. And then the other one is asterisk ptr2 is equals to 50, semicolon. So let's try to display this one on screen. See out first. So let's see the differences between without an asterisk and with an asterisk in ptr1 and ptr2. Okay. So if I'm going to pertain to the address of num1 is, the address of num1 is, you can use ampersand sign num1 or just simply ptr1. Okay, then value in num1 is going to use asterisk ptr1. Okay, so that's the differences. If you're talking about the address, just simply use the pointer variable. But if you're pertaining to the content or the value in that particular address, we use the asterisk sign followed by the pointer name. Okay, so let's have the next one. Address of num2 is, so this one is ptr2. Then the other one is value in num2 is asterisk ptr2. Okay, let's run this first. Okay, so if you're going to take a look at my example here, okay, the address of num1 that is assigned by the system, that was assigned by the system is this address. And for number 2 or num2, this was assigned by the system. And then if you're going to take a look at the content, okay, so we have to use the asterisk ptr1 equals 10 and asterisk ptr2 equals 50. So that means when we display the values of num1 and num2, the value will be 10 and 50. Since pointer ptr1 holds the address of num1 and pointer ptr2 holds the address of num2. So from the previous example, this is what is the illustration of what we did from the previous code. Pointer PTR is pointed to the address of num1. Pointer PTR2 is pointed to the address of num2. Then we assigned using asterisk PTR1 equals 10. That means we're going to populate num1 using the pointer variable PTR1. Since pointer PTR1 is pointed to the address of num1, then we can already populate the value with 10, as well as the same thing as num2. Now, what if we want to change the declaration of the pointer? So the other option is we can use the type definition. This one, type definition. And then we're going to make use of like an object or a data type. We can actually create parang this is a user data type, no? For the type definition. So this one is the first option, but how about the second option? Okay. So I'm going to omit this asterisk sign since I'm going to use type def. So I'll just use that as like that without the asterisk sign because I'm going to make use of type def. Then int. Then I'm going to use ptr type semicolon. So I'm going to use this pointer ptr type. So I'm going to use asterisk, type def int asterisk ptr type. Okay. And then this one, I'm going to use this as my type definition or data type. Instead of int, I'm going to use the variable name ptr type. So this means that since I already declare ptr type as a pointer variable, I can create more than one pointer variable without using the asterisk sign. Since I already used the type definition and my type definition is a pointer variable, okay, the name of the object is ptr type. So I'm going to use that object and these are the variables and this variable is already considered as a pointer variable because of this object and that is defined as type definition. So if I'm going to run this and execute this again, this is still valid. So this is the this is the second option. Okay, so this is the second option or this is equivalent to again int asterisk ptr1 comma asterisk ptr2. So this code and this code are just the same. Okay, this code and this code are just the same. Okay, so let's run again the code. Let's see what will happen. So still the same. Okay, so once we run and execute the code, the output are just the same. Okay, different declaration, but the same output. Okay, so there is a bit of an inconsistency in how C++ name pointer type. So if you want a parameter whose type is, for example, a pointer to a variable type int, then the type is written int asterisk as in the following example. Okay, so this one is also considered as a declaration of a pointer variable, but this is not the good practice on how you declare a pointer variable. Make sure that you always declare a pointer variable, okay, not beside the data type. It's always beside or together with the pointer variable, okay? Why? Okay, this one is accepted. Okay, but this one is accepted but dangerous. So take note of that. Okay, because of this. Why? If, for example, without the asterisk P2, that's fine. Okay, without the asterisk P2, if you do not declare this asterisk P2, only int asterisk P1, that's acceptable. But since there's another or additional pointer variable P2, do not put the asterisk beside the data type. Instead, you put it in the beside the pointer variable. Okay. So this is just another example on how are we going to consider the effect of pointer variables in our code. Okay, so let's just use our previous code, this one. Okay, so what will happen, for example, I have another declaration, num3. Okay, so num3. So what will happen is I want to point my pointer ptr2 to the address of num3 after this portion. So can I do that? Yes. A pointer variable can actually point to any other type of variable, to any variable which type is the same as the pointer variable. So if the pointer variable is integer type, then you can actually move your pointer variable to any other address. So what will happen here is, for example, so when you run and execute this code again, we know that pointer PTR1 is pointed to the address of num1 and pointer PTR2 is pointed to the address of num2. What will happen if I'm going to do this? PTR2 is equals to ampersand sign num3. Okay? Then I'm going to assign value for num3 asterisk PTR2 equals 100 semicolon. So I'm going to display now here. This one becomes 3, this one becomes 3, pointer 2, pointer 2. Okay, so what will happen is from the illustration, okay, so we have this. Previously, pointer PTR2 is pointed to the address of num2. Let's say, for example, I have created another variable and we name that as num3. Okay, so let's have this as 1,300. So what will happen is this pointer will not be pointed anymore. So at first, pointer PTR is pointed to the address of num2, but this time, after we execute this portion, we revise the pointer variable PTR2 to point to the address of num3. So what will happen is this portion will move here. Okay? So this time, pointer PTR2 is no longer pointed to the address of num2, instead to the address of num3. And if we're going to populate pointer PTR2, num2 will still the same value as 50, but pointer PTR2 will be assigned to 100 and num3 will be populated by 100. Okay? So in this case, I can display here instead of address of num1, num2 is a, I will not use PTR2. Instead, I'm going to use the ampersand sign num2 so that I can display the address of num2 still. And then value in num2 is, instead of asterisk PTR2, I'm going to use num2. Enter. Okay? So what will happen this time? The output will be pointer PTR2 will be the address of num3 and the output of the content is 100. Then we still display num2. Okay, we can still see the address of num2, but instead of pointer variable, we directly use the ampersand sign to num2 and display directly the value to the storage or to the address or to the variable of num2. So let's run the code. And L. Okay, so if you're going to take a look at this one, num2 is just the same as here, but instead of using pointer PTR2, use the ampersand sign num2. And then the value of 50. But this one, we use pointer PTR2 to point the address of a num3 and assign the value of num3 in as 100. Okay. Now, what if I do this code? Okay, so let's say, for example, I did this. Asterisk PTR1 is equals to asterisk PTR2, semicolon. So what will happen if I'm going to display the value where pointer PTR1 is pointed to and pointer PTR is pointed to? So if I'm going to see out value in asterisk PTR1, then let's display PTR1 and L, value in asterisk PTR2, then asterisk PTR2, next line. Okay, so let's go back to the illustration first. Okay, so our code now is asterisk PTR1 is equals to asterisk PTR2. So what will happen if this is the syntax or this is the code? Okay, pointer PTR2, let's have this one first. Pointer PTR2 is pointed to the address of num3 and the content. Take note that this is the content. The asterisk is getting the content. Okay, this one, getting the content. So that means it's just the same thing as if this is asterisk PTR2, when we are going to get the content where pointer PTR2 is pointed, we are going to reassign the value of asterisk PTR1. So that means, okay, pointer PTR2 is still pointed to the address of num3, and pointer PTR1 is still pointed to the address of num1, but we're going to change the value of where pointer PTR is pointed. This one is just the same thing as asterisk PTR1 equals 100. Why 100? Why equals 100? Remember that pointer PTR2 is pointed to the address of num3 and the content of that. Take note, we are using the asterisk sign here, that the content or the value inside that particular storage or variable is 100. So we're going to make this one also as 100. Okay? We only change or revise or alter the value inside the variable, okay, not the address. So if we're going to run this code, pointer PTR1 and pointer PTR2 contains the same value but in different storage, num1 and num3. Let's run again the code. Okay, so this time, asterisk PTR1 is now 100 since we have asterisk PTR1 equals asterisk PTR2. We are copying the content where pointer PTR2 is pointed and copy it to where pointer PTR1 is pointed also. Okay. Okay, next, what if we have this code? PTR1 equals PTR2. This time, there's no asterisk sign. That means we are not talking about the content. But this time, we're talking about where pointer PTR1 and PTR2 is pointed. So let's go back in our illustration. So our case now, or our syntax now is PTR1 equals PTR2. So it's not an asterisk sign. There's no asterisk sign. So what will happen? If my pointer PTR2, so let's see the right operand. Okay. Pointer PTR2 is pointed to the address of num3. So what will happen to pointer PTR1? So I'm going to change the position of this arrow. Since I need to also equate whatever or wherever pointer PTR2 is pointed, I'm going to point also my pointer PTR1 to where pointer PTR2 is pointed to. So again, I'm going to change this and put it here. Sorry, this one. Okay. So this is the code. So that means pointer PTR now is no longer pointed to the address of num1. Since we have this code, that means pointer PTR1 will be pointed to where pointer PTR2 is pointed. And that is pointed to the address of num3. So again, once we run and execute the code, what will happen to the output here? The output or the content will be the same, 100 and 100. Okay. Let's try to simulate this code and how are we going to do to see the final output. So later on, let's have the final output. So in this case, for line 1, we declare two pointer variable, pointer A and pointer B. So let's just have an illustration of that. So I have two pointer variables. Okay, so I have two pointer variables. This is pointer underscore A, and then the other one is pointer underscore B. So since this is just a declaration, you just put a question mark inside the box. That means there's no address yet assigned for pointer PTRA and pointer PTRB. Next, line 2. Line 2 is just a declaration of a simple variables. I'm going to declare two variables as well. So this one is num underscore C, and the other one is num underscore D. So num C already assigned a value of 4, and num D assigned also a value of 7. So that's not question mark since there is already an assigned value. Now, in this case, we're going to point pointer PTRA to the address of num_c. So take note that this is num_c contains a value of 4. So we're going to point this pointer PTRA to the address of num_c. Let's say, for example, the address is 1100XH. So I need to point my pointer A to the address of num_c. So that means this one will be 1100XH. Next is I'm going to assign pointer B to where pointer A is pointed. So I'm going to copy this one and put it here. Okay. And then I'm going to also use another pointer variable. And this is PTR underscore B. And I'm going to point this pointer also to where pointer PTRA is pointed. So this one is also pointed to this address. Basta nakaganyan siya. So this one is also 1100XH. Okay, so this one is pointed to the address, or let's just move this one here. That is just the same. Here. So to the address. So that's the same. Okay. So next, let's have cout asterisk PTRA space asterisk PTRB. So that means we are going to display the content where pointer PTRA and PTRB is pointed. So this becomes 4, and then I have space, and then 4. Okay, next, pointer B equals ampersand sign num B. Okay, so initially, I'm going to copy this and paste it here. So this time, pointer B will not be pointed anymore to the address of num_c, but instead, let me just copy this and paste it here. So this time, I'm going to delete that portion, and then I'm going to point this to the address of num_d, and then the content of D is 7. So this is now the new state of where pointer B is pointed. This time pointer B is pointed to the address of num_d based on line 6. So this is already the illustration of pointer A and pointer B. Pointer A is still pointed to num_c, and pointer B is still pointed to num_d. So if we're going to display the value of where pointer A and pointer B is pointed, so this becomes 4, and then space 7. So if you're going to take a look at this one, 4 4, this one is 4 7. Next, going to copy this one again. I need to move this here. So I'm going to copy this. Okay, so this case, pointer A, asterisk PTR A equals asterisk PTR B. PTR B contains a value of 7. So this is just the same thing as asterisk PTR A equals 7. Since pointer B is pointed to this address and the content is 7, so that is the same thing as this code. So that means I'm going to change 4 to 7. Then this case, C out, asterisk PTRA. Okay, this is 7. And then I have space, asterisk PTRB, another 7, backslash N means next line. Okay, then we're going to output the value of num-C. Num-C, if we directly display num-C, still the value is 7. So 7, space. And then this one is just the same thing as getting the content to the content of address num-C. Content of address num-C. So this is also 7. So if you're going to take a look at the final output here is all those with C out. So the first C out is line 5. So this is 4, 4. Next C out is 4, 7. And then lastly is 7, 7, 7. Okay, so if you're going to take a look at this one and this one, the output of the program are just the same when we simulate the code of this program.